Hi, boys. This is really quickly. At the end of class today, when I was talking to Gary and answering a question of his, I caught a very quick but important righto on the board for me. I didn't catch it in our last minute shuffle. This is the last question that we talked about in class right here, these 3 points, and I asked you to find the equation of the plane, okay? And we know an equation of a plane has the form ax plus by plus cz plus d equals 0. And we recognize that the coefficients of x, y, and z, that's vector n, okay? And just to review, what Trent did was he created two vectors right here, these two vectors, and he just chose b1 minus a1, b2 minus a2. You could have picked any three vectors. I will say, just be mindful of the fact that you need to make sure that the vectors you pick, you want to have a common point of initial common point, just for the sake of not having to rewrite this every single time because it's quite long. He called this vector u, he called this vector v. I said, and here's where my righto and thinko came. You know, the equation of a plane comes from the relationship that vector n dotted with any vector on the plane that has to equal 0, and here was my gross misstep. This vector u, Trent had named it as vector u here. Vector u here is going to have just constant components. The vector here that should be there, this vector has to be any vector on the plane, okay? Because any vector on the plane, not a specific vector on the plane, because Trent named this vector a specific vector, right? So the two specific vectors u and v were used to get vector n, and we know that vector n will have some components a, b, c. Again, don't confuse my a, b, and c here with the a1, b1, c1 up here. But the point is, this vector, the any vector on the plane, you have to have variables involved. So it has to be x minus x naught, comma, y minus y naught, comma, z minus z naught. Any vector on the plane means any point x, y, z on the plane that you use to create a vector with x naught, y naught, z naught, which is a known point on the plane. As far as known points go, you had 3. You can use any one of these. I'm just going to choose a1, a2, a3. So really the equation of the plane, when we left off with, it's u cross v dotted with any equation, any vector on the plane. So this should be x minus, I'll choose a1, comma, y minus a2, comma, z minus a3, okay? This dot has to equal 0. Now, once again, this here was a question I gave you without any specific numbers in here for these 3 points. But as you can see here, just pretend with me for a second, if you had numbers in here, understand and notice that vector u here would be a vector with, constant components. Vector v here would be a vector with these constant components. And when you cross u and v here, you're going to get an actual vector with these constant components. And when you, again, because this, just might be mindful, right? This is this. When you dot a vector with, and this vector is n, by the way, when you dot it with this vector, and again, you're going to have constant values here for a1, a2, a3, and you do the dot product and you walk it through, what you're going to get here at the end of the day is an equation of this plane. So again, I may have been a little bit overly verbose, but I wanted to make sure I clarified that, because at the very end of the class there, I know that I was kind of shuffling through very quickly, but please make that note in your notes, okay? Thanks so much, and you have 2 questions for homework. Goodbye.